Welcome guys. Today we are going to look at how to organize quantitative data into a frequency distribution table. So you must watch this video till end because I'll talk about everything you need to know on this topic, and this will help you understand the topic better. So if you are new to this channel, please subscribe to the channel. Thank you. So without wasting much time, let's start. So let's take this raw data. I'm going to group it into a frequency distribution table. So to do this, now whenever a question gives you an interval, then you follow it in that order. Okay. But in case you don't have interval in the question, then you need to follow the procedure I'm about to follow now. And the procedure goes like this. Now, the first thing you need to do is to call the 2 to the k rule. Okay. You call the 2 to the k rule. And the 2 to the k rule states that 2 exponent k should be greater than or equal to n, where k means number of classes and n means number of values in the raw data. Okay, so when you count all the values in the raw data, you count them one after the other, you get 51. So n is 51. So you can now replace 51 with the n. So you now have 2 exponent k should be greater than or equal to 51. So now what we have to do is to find the value of k. Now to get the value of k, you ask yourself, 2 exponent what will be greater than 51? Are you with me? So let's check. When you check 2 exponent 1, 2 exponent 1 is what? Is 2. So 2 is not greater than 51, so k cannot be 2. When you check 2 exponent 2, 2 exponent 2 is equal to 4. 4 is not greater than 51, so k cannot be 2. 2 exponent 3 is 8. 8 is not greater than 51, hence k cannot be 3 too. 2 exponent 4 is 16. 16 is not greater than 51, so k cannot be 4. 2 exponent 5 is 32. 32 is not greater than 51, so k cannot be 5. 2 exponent 6 is 64. 64 is greater than 51, so k can be 6. 2 exponent 7 is 128. 128 is greater than 51, so k can be 7. 2 exponent 8 is 256. 256 is greater than 51, so k can be 8. So 6, 7, 8 going are possible values of k. Okay. So somebody can decide to choose to make k 7, someone can decide to make it 8, and someone can decide to make it 6. But it is the best when you make it, when you take the one which is closer to the 51. 64 is more closer to the 51 as compared to the others. Okay, so you take the value, the least value, the one which is more closer to the n. Okay, you take the one which is more closer to the n and take its k value. So we take our k to be what? To be 6. I hope that's clear. After that, you also find something we call the class interval or the class width. Okay, but in this lesson I'm going to call it interval. So the formula for the interval states that interval should be greater than or equal to h minus l divided by k. Are you with me? Now the h stands for the highest value in the raw data. So the highest one is 15, as you can see. And then L stands for the lowest value. So when you check through, the lowest value is 1. I think so. Yes, 1. Isn't it? And K, we've gotten our K to be 6. Okay. So you substitute. So when you substitute 15 for H, 1 for L, and then 6 for K, 15 minus 1 divided by 6 should give you 2 whole number 1 over 3. And 2 whole number 1 over 3 is 2.33, isn't it? Yes. Now, but you should make I such that I should be greater than what you get, 2.33. Okay. Now, since the values are in whole number, okay, since the raw data they are all in whole number, then you should approximate this to a whole number, but that whole number should be greater than the value because there's a greater than sign here. Okay, So when we approximate this to a whole number which is greater than it, we are going to get 3. So I is equal to 3. Are you with me? Now some questions will tell you what to use. Some questions will be like, use your interval, take interval as 3. Okay, some questions will tell you that. But if you have a question and there's nothing like that, that's how you should go by it. Okay, so we now know our k to be 6 and our I to be what? 3. So without wasting much time, let's prepare the table. Now to prepare the table, we know our k to be 6, isn't it? And I to be what? 3, interval. I told you k means number of classes. So what this means is that you should create 6 classes. 1, class 1, class 2, class 3, class 4, class 5, class 6. Okay, apart from where the titles are, the frequency, the interval, and the likes, you should create 6 classes. 1, 2, 3, 4, 5, 6. That's the meaning of the key. So we are done with the key. Okay. Now the next thing you are going to do is to choose the lower class limit to start from. Okay. You are going to choose the lower class limit to start from. And there's a rule that the lower limit of the first class, okay, should be an even multiple of the class interval. But that rule will be difficult to apply in this question. If it was another question, I think that rule can be easy. But looking at the nature of this question, that rule will be difficult to apply. So let me just show you one way of doing this simply. What you do is you start from the lowest value. Okay, which value is the lowest value here? The lowest value here is what? 1. So we start from 1 by fixing 1 as the lower limit of the first class. So 1. Are you with me? Then after that, add the interval to the 1. Okay, then you write it in the second class as the lower limit of the second class. So we add the interval to 1 and that gives us 4. So that becomes the lower limit of the second class. To get the lower limit of the third class, you add the interval to this also and that gives you what? 7. So you continue. You add the interval to 7, you get 10. Add the interval to 10, you get 13, and then add the interval to 13, you get 16. So you are going to bring hyphen for all. Okay, we put hyphen for all. Then after that, we are now, all these are called lower limits. Okay, they are lower class limits. So we need to find the upper class limits. Now to get the upper class limits, are you with me? What you're going to do is, there's a rule too that you shouldn't have overlapping classes. So to respect the rule, what you have to do is to subtract 1 from the lower class limit of this place. When you subtract 1 from 4, you get 3. So you write that 3 as the upper class limit of the first class. Or you ask yourself, which value, which integer comes before 4? It is 3. So you get a 3. Which integer comes before 7 is 6. Okay, so you write 6 for the upper as this place. Or you can say 7 minus 1. Okay, you subtract 1 from the lower class limit of this class to get the upper class limit of this class. When you do it like that, then you are respecting the law that says that there shouldn't be overlapping classes. The classes shouldn't lap. You shouldn't write 7 here and 7 here. Do you get it? Yes. So to get this place, which value comes before 10 is 9. So you write 9 there. Which value comes before 13 is 12. So you write 12 here. Which value comes before 16 is 15. So you write 15 here. So to get this place, you can check the difference between upper and lower. The difference means when you subtract them. Okay. When you check the difference between the upper and lower of this place is 2. 2. That's 9 minus 7. 2. So you must make this place to be the same, like 2. So we can just add 2 to 16 to make it 18. So 18 minus 16 is 2. You see that the difference is the same throughout. Okay, the size is the same throughout. Okay. Let me erase the upper class limit and show you another way of doing that. Another way of doing this is you find the upper class limit of the first class. Which integer comes before 4 is 3, right? Or 4 minus 1, 3. Okay. Then to get the rest, what you do is that you'll be adding the intervals accordingly. just how we did it in the lower class limit. Okay, so let's add the interval to 3, to this 3 here. When you add the interval, you get 6. Okay, you add the interval to 6, you get 9. You add the interval to 9, you get 12. You add the interval to 12, you get 15. Then we add the interval to 15, we get 18. You see that we've ended up getting same answer. Right. Now, what do we do next? We count all values from 1 to 3 here, and then write it as a frequency. Are you with me? When you look throughout the table, you realize that 16 to 18, class 16 to 18 will be useless. What will make it useless? When you look at the raw data, there's nothing like 16, 17, and 18 there. So it will become useless. But we need to use all the 6 classes. We shouldn't make any of the classes useless. So because this place is now useless, I can't use my arrangement anymore. So I need to cancel out this. I need to erase them or cancel it out. So I'm going to re-prepare a new table. You get me? Now, to prepare a new table, that's why it's advisable that instead of starting from the lowest value, okay, which is 1, like what I told you to start from 1, it would have been better if you had started from a value lower than the lowest value, which is 0. Don't go to the negative part. So starting with 0, so we add the interval to 0. When we add the interval to 0, what do we get? We get 3. Okay, we add the interval to 3, we get 6. We add the interval to 6, we get 9. We add the interval to 9, we get 12. Then we add the interval to 12, we get 15, isn't it? Then we bring the hyphens. Okay, we bring the hyphen means 2. Okay, to TO, 2. Okay, so we bring the hyphens. Now, to get the upper class, I hope you remember that. You can bring the first one, that's 3 minus 1, or which value comes before 3 is 2. Okay, so we write 2 here. Then to get the rest, you can be adding the intervals to them one after the other. So when you add the interval to 2, you get what? 5, isn't it? When you add the interval to 5, you get what? 8. When you add the interval to 8, you get 11. When you add the interval to 11, you get 14. And then when you add the interval to 14, you get 17. Okay, so you are done with the class interval. So all these places are called the lower class limits or lower limits, and these are called the upper class limits or upper limits. Okay, so we are done with the class interval. So let's see the frequency. We create a new column for the frequency. Now, what to do is you count from 0 to 2. So let's count from 0 to 2. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 values from 0 to 2. Okay, so write 9 here. So 9. Are you with me? Then you also count all values from 3 to 5. You count all values from 3 to 5. So when you count them properly, please do that. You will get 21. When you count from 6 to 8, you get 13. When you count from 9 to 11, you get 4. When you count from 12 to 14, you get 3. When you count from 15 to 17, you get 1. Okay. So you create another column also for class midpoint. Okay. So let's see how to find class midpoint. To find class midpoint, you add the upper class and the lower class and divide it by 2. So lower class plus upper class gives you 2. 0 plus 2 is what? Is 2. Divided by 2 gives you 1. So the class midpoint of this first class is 1. Now to get a class midpoint of the second class, it will be 3 plus 5 divided by 2, isn't it? So 3 plus 5 gives you 8, and 8 divided by 2 is what? 4. Okay. Then for the next class, 6 plus 8 is what? 14. 14 divided by 2 gives you 7. 9 plus 11 gives you 20. 20 divided by 2 gives you 10. Okay. 12, 14 gives you 26. And 26 divided by 2 gives you what? 13, right? 15, 17 gives you what? 32, right? And 32 divided by 2 gives you what? 16. So that's how we find the class midpoint. Another name for the class midpoint is class mark. Okay, the class mark. Okay, so that's why I've written X here. So in case you want to find your mean and you need fx, the sigma fx, this is what you are going to consider as your x, okay, the class midpoint. So it's also known as class mark. Now let's also look at another thing, okay, which we call class boundary. How do you prepare class boundary? This is how we do it. Please pay attention. Now what you are going to do is you go to the second class, okay, and take the lower limits of the second class. Then you take the upper limit of the first class, okay. Then you find the difference between them and divide it by 2. So 3 minus 2 divided by 2, okay. And 3 minus 2 is 1, isn't it? Divided by 2 gives you 0.5. I know you solve different questions where you always get 0.5, isn't it? But make sure you always check. The reason you must check is there are some questions that you won't get 0.5. If you've solved a lot of questions, you would have come across what I'm talking about. Okay, there are some questions that you won't get 0.5. That's why it's very, very important to check in every question. Okay, don't assume that it's always 0.5. No. Okay, so 3 minus 2 is 1, divided by 2 is 0.5. So what we are going to do is, to understand this concept better, we are going to consider the lower limit as Peter, and then we consider the upper limit as Paul. So rob Peter to pay Paul. So how much are we robbing from Peter to pay Paul? We rob 0.5 from Peter and pay Paul 0.5. Are you with me? So let's rob Peter to pay Paul. And when we say we rob someone, meaning we are subtracting from that person, isn't it? We are deducting. And then when we pay someone, meaning we are adding to the person, isn't it? So let's rob Peter 0.5. Now Peter has 0. And let's subtract 0.5 from Peter. So 0 minus 0.5 gives us what? Negative 0.5. Please use your calculator. Okay. Then we add the 0.5 to Paul. So 2 plus 0.5 gives you what? 2.5. So you are going to write that here. So negative 0.5 to 2.5. The hyphen stands for 2. Okay, TO2. Okay, so negative 0.5 to 2.5. Okay, now then we go to the second one. Let's rob Peter again and pay Paul. So we rob Peter of 0.5. So 3 minus 0.5 gives you what? 2.5, isn't it? Then we pay Paul. When we add 0.5 here, we get 5.5. So we have 2.5 to 5.5, as you can see. Then we do that here too. 6 minus 0.5 gives you what? 5.5. Then we add 0.5 to 8, it gives us 8.5. 9 minus 0.5 gives us what? 8.5, isn't it? And then 11 plus 0.5 gives us 8.5 to 11.5. So you do this class to search. 12 minus 0.5 is 11.5. Then we add the 0.5 to 14, and that gives us 14.5. 15 minus 0.5 gives us 15.5. Then we add it to 17 to give us 17.5. So this is the lower class boundary, and this is the upper class boundary. Lower class boundary, upper class boundary, like that. Okay. Now let's also look at another thing we call the cumulative frequency. So let's see how to find cumulative frequency. Now to find cumulative frequency, okay, for the purpose of our study, I'll be calling it CF, okay, and this is frequency F. Then I'll be calling this CF, okay. Now, to find cumulative frequency, for the first class, the CF of the first class should be F of the first class. Okay, so you are going to repeat the F of the first class as the CF of the first class. So that's 9. Okay. Now to get a CF of the second class here, okay, there are different ways of doing this, but I want to use this so that you can understand the concept better. Now to get a CF of the second class, F of the first class plus F of the second class, and that gives you 30. Okay. Now to get a CF of the third class, you say F of first class plus f of second class plus f of third class, and that will give you the CF of the third class. That's 43. Are you with me? To get a CF of the fourth class, you say f of first class plus f of second class plus f of third class plus f of fourth class, and that gives you the CF of the fourth class. To get a CF of the fifth class, you say f of first class plus second class plus third plus fourth plus fifth, and that gives you the CF of the fifth class. That's 50. To get a CF of the sixth class, you say f of first class plus f of second class plus that of third class plus fourth class plus fifth class plus sixth class, and that gives you 51. Now before you proceed, you have to check total frequency is what? Sigma f. Okay, total frequency gives you 51. Please always check if the last CF is the same as total frequency. If it is the same, then you are on the right path. But if they are not the same, you should know you've made a mistake in your computation somewhere, so you should go back and recheck. Okay, make sure your last cumulative frequency is equal to the total frequency. Okay, it's very important. Check that. Now let's also look at another thing we call relative frequency. So let's prepare a new column for relative frequency. So this is a relative frequency. To find the relative frequency, this is how you do it. You will take the frequency of the class. Okay, you know, I told you must know the total frequency, which is 51. So to find relative frequency, you take the frequency of that particular class and divide it by total frequency. So for the relative frequency of the first class, you take the frequency of the first class divided by the total frequency. So 9 divided by 51, and that gives you 0.1765. I have decided to leave my answer in 4 decimal places. When you check other books, maybe the answer is in 3 decimal places. Okay, but I prefer to use 4 decimal places. Okay, so leave the answer in 4 decimal places. Now, for the relative frequency of the second class, you take the frequency of the second class divided by total frequency. So 21 divided by 51. Okay, so that gives you this. So for the third class, you take the frequency of the third class, 13, divided by 51. Then you get your answer. And this too, for the fourth class, the frequency of the fourth class is 4. Okay, divided by 51. So you get the answer. And then for the fifth class, the frequency of the fifth class is 3 divided by 51. Okay, so you get a relative frequency of the fifth class too. Then for the sixth class, the frequency of the sixth class is 1, and then you divide it by total frequency, which is 51, and that gives you 0.0196. Okay, so when you add all the relative frequencies, you must get 1. Okay, you must get 1. If you've done your approximation well, okay, you must get 1. If you've made a mistake in your approximation, you might get 0.99 or 0.98. Okay, so but make sure you always do your approximations very well. If you do 3 decimal places for the first one, make sure you use 3 decimal places throughout. I use 4 decimal places for the first class, so 4 decimal places throughout. Okay, yeah. Let's also look at another thing we call cumulative relative frequency. So I've created a new column for cumulative relative frequency. Now to find the cumulative relative frequency, please pay attention. Now let me take you back to something. When we wanted to find cumulative frequency, we used frequency to find cumulative frequency, isn't it? So here too, we can use relative frequency to find cumulative relative frequency. So to do that, I told you that cumulative frequency of the first class should be the frequency of the first class, isn't it? So you are going to apply same method here. The cumulative relative frequency of the first class should be the same as the relative frequency of the first class. So you write the relative frequency of the first class as the cumulative relative frequency of the first class, 0.1765. Now to get the cumulative relative frequency of the second class, okay, I'll be calling this CRF, cumulative relative frequency, and I'll be calling this RF, So CRF of second class should be RF of first class plus RF of second class, and that gives you 0.5883. Now to get CRF of third class, it should be RF of the first class plus second class plus third class, okay, and that gives you CRF of the third class. Now to get a CRF of the fourth class, add from RF of first class to second class to third class to fourth class, okay, and that will give you CRF of the fourth class. Are you with me? To get a CRF of the fifth class, you say RF of first class plus that of second class plus third class plus fourth class plus fifth class, okay, and that will give you the CRF of the fifth class. And then to get a CRF of the last class, you say RF of first class plus second class plus third class plus fourth class plus fifth class plus sixth class. Then you get this two. Okay. Now remember something. I told you that you should always check total frequency. So total frequency was 51, and then you check the cumulative frequency. Check if the cumulative frequency is the same as the, okay, so that you know if you've done your calculation well over here, okay. It applies here too. You know, total relative frequency is 1, so you have to check if the last CRF is equal to the total relative frequency. I hope that's clear. So that's all I want you to know on this. So thank you for watching. Remember, if you are new to this channel, subscribe to them, share the videos. Thank you.